Okay, so in this one here, we're going to simplify this radical. As you can see, we're going to attempt to do it with no calculator. Just because it ends in an even number, I know that you can divide by 2. Remember that? The divisibility rule. So if I divide the 4 by 2, I get a 2. If I divide the 4 by 2, I get another 2. And the 8 by 2, I get a 4. So 2 times 224 is 448. Again, it ends in an even number. I know I can divide by 2. 2 divided by 2 is 1. 2 divided by 2 is 1. And 4 divided by 2 is 2. Now it's a little bit easier. I can easily get half of that, right? Half of 100 is 50, and then half of 12 is 6, so that should be 56. Nice. Now if you remember your multiplication tables, 7 times 8 is 56. Now we have a smaller number here, 4 times 2, and then the 4 becomes 2 times 2. So in essence I have 6 2's right there. You see that? So that'll be 1, 2, 3, 4, 5, 6. 6 2's. And I also have 1 7. And I'm going to try to make them into squares, because if you recall, the square root and the square are inverses of each other. They cancel each other out. So they make each other disappear, and it would leave you only the number that's there. Okay, so don't forget, the square and the square root cancel each other out. Okay, so in this case here, I can rewrite this as, there's 2 right there, you see that? So that's 2 squared inside the square root. Here's another pair, that's another 2 squared, and here's another pair right there, that's another 2 squared. And of course the 7 is by itself, right? And the reason for that is so that I can eliminate or cancel those squares with the square root. That means that the little square root symbol is out. The only thing left over is that number. That number is a 2. That number is also a 2. That number is also a 2. Okay, and then you multiply those 3 numbers. So you end up with 8. It's outside of the radical. The 7 is inside of the radical. Okay? As far as the letters are concerned, I can do the same thing. Remember that I have 3 x's right there, right? So I can rewrite that as x squared and then my x. I have 3 y's. I can rewrite that as y squared and an extra y. And I have 4 z's. 1, 2, 3, 4. I can rewrite that as z squared and another z squared. Again, why the square? So because the square root and the square eliminate each other, right? So you don't have that radical symbol anymore for this one. It's just an x. You don't have it for this one. It's just a y. The radical and the square are gone. It's just a z. No, we hear the same thing. It's another z. So these are outside of the radicals. So outside of the radicals, I have an x, a y, and a z squared, because there's 2 z's that are outside. Inside, I have this x and this y right there, right? These guys are still inside. So guess what? You're going to write them inside, and that's just xy. So that's pretty much it. You're done right there.